Greetings and salutations, and welcome back to more Astroneer. Now, the idea is to get to DeSola, okay? Now, the problem with this is I'm going to need some ammonium. And the reason I'm going to need ammonium is because, quite simply, I don't have enough hydrazine to... because I've only got 7 launches left. And in order for me to do anything worth note, I need enough hydrazine to make the trip. I've got everything all stacked up and ready to go. And yes, I can attach all my little packagers to the outside. The problem I'm going to have is I have to get enough power generation to activate Calidor. Because that's where I'm going next, is Calidor. Now, the problem there is I don't know how much generation that's going to need. Plus side is I can always pick up some stuff while I'm there and potentially use that to my advantage. Or I could take more batteries along with me. It only produces 1 unit, which is a shame. We'll start taking some other batteries with me. That's not even hooked up to anything. Take that with me too. Alright. I didn't even attach the hydrazine to the bottom of it. I have enough for 7 launches. We're good. But I'm going to get to Calidor. We've already done DeSolo and Silva. There's Calidor. Now, I'm pretty sure I have a base on Calidor somewhere. Yeah, it's right there. Cool. I already have something here. So now I've got a little bit extra fuel. So I've already got something here that can generate stuff. The paper is upside down. Alright. I've got trailers. Whoa, 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 whoa. Alright. Forgot that I had a rover here. Did I already activate the beacon on here? I don't see the exterior node being active. No, it is not active. Which means I didn't have enough power before. Hopefully we have enough this time. This is the trouble. This is the trouble. No worries. This is the point of having a portable oxygenator. Because now I can come back over here, hop up here, go back this way, plug it in, and see if I have enough power to get this thing to power. Nope. I still don't. Which means I need more RTGs. So, that means I need to get lithium, I believe. I think it's lithium. I'll have to look. I think I have a printer back here. There's Ruby. Not that I need Ruby. But I need... to see if there's a printer. Not a research chamber. Not a solar panel. Printer! Did I not have it? I thought I had it. Nanocarbon alloy and lithium. And I'm gonna need what? Two nanocarbons, 2 lithium? Maybe? What's it take to get nanocarbon alloy? Oh god. Alright, so let's see here. If I get lithium and I get the nanocarbon alloy, I can only make, if I make one of those, that replaces the same amount as the mini RTGs. Because these all produce 1. So I would end up using up 4 of these to make, effectively, it would be 4 of them together. That seemed like it was draining an awful lot. Like a lot. So if I was to use... How much does a miniature generator produce? That produces 9. RTG produces 4. Aluminum and tungsten's a lot easier to get. Runs on carbon, though. That's a problem. So I need to replace... I need... Source 502. 512, sorry. Produces So wait a minute. If that... I may have a solution here already on Calidor. Because then it holds 1,000. And if I could drain enough of the power off of these, I can effectively power that up and then bring the batteries back. Once I power up the node, I can then tunnel to the center. That may be the plan. Now, I know that like Aatrox requires even more energy, so I don't know how I'm going to go about completely doing this. We're going to give it a shot, though. Really? Really? I don't want to go too far forward because I need to plug it in. All right. Oh, that'll work. That works amazingly. Nailed it. Dim node interior elevation. Perfect. Now we can go and get down in there. Ooh, that's a lot of ammonia. I don't have an atmospheric... I don't have a lab. Also don't have hydrogen. I was gonna say I can make hydrazine here. I have to take the batteries back, plug those back in, and then I have to go tunneling. Come on. This is ridiculous. Good. There, the battery banks are there. Oh, research. Alright. Draws 1 IU, draws 1 IU. There. And now we need to go off here and start tunneling toward the center of Calidor. Then I need to figure out what Calidor needs and give it what it needs. It's so tough to give these planets what they need sometimes because it's... You have to sit there and look at it and then realize, oh yeah, that's what they need. I'd like to fill this soil canister because I have a feeling I'm going to need it for when I get further down and closer to the core. Calidor seems like it's a pretty big planet. I know that Aatrox is tough. Wow, that's a lot of Wolframite. Look at it go. And there's the ammonia. Imagine if I had a resource canister. What is that over there? Sorry, partial detour. Weird. Never seen those things before. Ah, yes. We've hit the tough layer of soil. Mind you, this is the highest powered drill. Highest powered drill available. And it's very tough to get through. I love how it says we're in the core, but we're nowhere near the core yet. We'll get there, though. And just think, this is the easiest way to do it. Not the quickest. The quickest would be actually to be like your own astronaut going down the drill strength 3 or whatever. Okay. Interesting. Looks like a tongue. Anyhow, let's see what we got down here. Alright, what do you need? You need... What do you need? What is that icon? That Resipound? Uh... Resources. It's not compound. It's not ceramic. It's not a gas. Explosive powder. You need explosive powder. Okay. Which means I have to go to Aatrox. Okay. Don't go doing that, Rover. Um. Okay. Oh, no, 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 no. Come on. Talk about getting screwed. Okay. Slowly and carefully now. If I could just turn this rover around. I could build right to that ramp and then get up out of here. That's bad. That's very bad. Huh. Given the low gravity of the core, maybe it's not lethal. I'm hoping. He says with a monicum of saved it. Says with a monicum of hope and a glimmer of hope in his eyes. I don't even think I could tunnel through that up there, but okay, I can. But what I should do is this. What in the world are you doing, Rover? Relax. Okay, it needs explosive powder. Okay. That was a bit too close for comfort. Huh. Obelisk. I know what this is a perfect job for. Grab the... Perfect. I have the winch. So now I can haul this up and out. I knew that winch was going to come in handy. Didn't know that this was an obelisk, though. It's kind of weird. Let's see if I can research it in the researcher's name. Maybe. Who knows? Maybe it'll just explode when I get it to the surface. I've never seen these things before. And the winch was a great idea. I sat there and I thought, man, am I really ever going to use the winch? I literally had that thought earlier today. Apparently, yes. I'm going to use the winch. Okay. Well, I can't research it. And I don't know what it does. Cool. And I don't have a machine to grind it, so I don't know if it can be ground into pieces. I have to know. If I winch this to the spaceship, can I drag it with me to another place? Let's find out. I hope. So I need to make explosive powder, which means I need to go to Aatrox. Doesn't appear as though there's a winch is here, but, you know, hard telling, might be. Do I have a base on Aatrox? There's a lot of landing zones. I think I have one. I had to have had one because I put an atmospheric condenser here to get sulfur. I believe. I think that's it. Certainly is. I don't need helium, I need sulfur. Okay, well, this clearly needs more power. So I need the sulfur to make explosive powder, and I need 3 explosive powder. How many does each explosive powder take? I won't know. And no, it did not bring the winch along with it, which is sad. So the winch is still on Calidor. Very sad day. And now we have to go back. Oh yeah, we have a tapper too. Now we have to go back to Silva. Because that's where my only chemical laboratory is. It's the only place I have that has an actual, like, chemistry lab. That's the words I was looking for. Which is a shame, if you ask me, because I should have brought one to somewhere else, but whatever. I need at least 2. Explosive powders. For Calidor. And we'll see what it requires. I know it requires sulfur. That much I do know. Alright, so I got sulfur. Carbon, carbon, and sulfur. Sweet. And I need 4 carbon to make 2 of them. Perfect. Perfect, he says, as he doesn't have any organic. And now I can come back and burn these. Because you don't really smelt them, you burn them. That's how it turns your organic into carbon. Once I have those carbons, I can get the explosive powder. How many launches do I have left? 9. So that's 8. Goes to Calidor, comes back. That's 7. I have to drop the one off there at the space station satellite. I had to drop off one of those truncated pentachorons, like over there. And when I bring that back, I'm going to bring that one back to here. I want to bring that all the way over to the other thing. I wonder why it always does that. That plays the music. Didn't even use all that much sulfur. It used 2. Nice. I land on Calidor, what's going to happen is I'm probably going to land right on my winch and make the space shuttle go pop off the landing pad. Calidor. And just think, I set out to do this whole Calidor thing, and I'm going to have it done. Landing pad. There's a beacon here. Technically, I could just teleport. Actually, I can't teleport. Come to think of it. What I am going to do is I'm going to try to do this whole, like, Battletoads style tunnel. Turbo tunnel here. Dude, I still want to make one of those. One of those turbo tunnels. Just you just throw on the old Battletoads theme for Turbo Tunnel and you just build this. Of course, I can't record it because, copywritten music and all. I mean, does it suck? Yeah, it sucks when that happens. But at the same time, it's like, you're just walking on air, dude. At the same time, though, it's like, yeah, I understand it. Like, I understand why they don't want people using copywritten music. I totally get it. When you really boil it down, right, to the reasons why, it's like there's so many times. Like I had in GTA, for example, I had so much of the music pop as copywritten, and that I had to have the YouTube AI or whatever, like, take it away. It was insane. Embedded in a truncated pentachoron. Oh, cool. But if I go there, I think it's just gonna. I won't be able to get back. You know what? I'm gonna try it. Because there's a couple others there that are different. Cool. Like, you can even look out and see them. Like Silva, Calidor, you know, Visania, Novus. That's so cool. Huh. I made it back. Interesting. Definitely not my way of traveling that I would enjoy, but, you know, if people like it, they like it. Teleportation would not be fun if you think about it. Like, realistically, put yourself in the shoes of a teleportation subject. Okay, like, really think about it. You're basically telling this individual that you are going to transport him via almost like compressed light from one location to another instantly. I mean, at the speed of light. Now, obviously, intergalactic travel, barring any wormholes or warp gates, just to get to the next star system would take thousands of years, right? And I'm not talking thousands of years with conventional travel. I'm talking thousands of years with even teleportation, light speed travel. I mean, when you have something that's like, oh, it's 100 light years away, it's taking light 100 years to get there. So you teleport from Earth to, say, some planet 100 light years away. It's going to take you 100 years at the speed of light to get there. Not feasible. Which means you'd have to move twice the speed of light, and even then it would take you 50. Still not feasible. So now what's the solution here? Well, you can't travel at the speed of light. You can't travel twice the speed of light. You'd have to travel 4, 5, 6, 7, 8 times the speed of light. If that. Let's say you were to travel 8 times the speed of light. It would take an enormous amount of energy, number one. Because you'd have, what, E equals mc to the power of 8. C to the 8th exponential. Nope, don't want that. Have any more room for ammonium? No. I have 4, which is fine because it's 2 hydrazine, which is perfect for me because that's what I need to fuel the rocket, of course. But nevertheless, you're talking to the power of 8. People would say, why would you say E equals MC 8? Well, if you look at E equals MC squared, that is the amount of energy required to move mass, m, to the speed of light, which is the speed of constant squared. Now, everybody says, well, this is just, gravitational relativity. It's not. Nothing about that says anything about gravity. Nothing about that says anything about relativity. That is the amount of energy required to move mass, the speed of light squared. Now, why would you want to move mass to the speed of light squared? What do you gain? Just moving mass at the speed of light. E equals mc. The amount of energy to move mass, the mass or volume of an individual, because mass and volume are interchangeable, the amount of the amount of energy required to move the mass of an individual to the speed of light is going to be enormous. So you're trying to do this to the speed of light squared. What are you hoping to achieve? Well, let's say you can get to 8 times the speed of light. Beautiful, right? Right. So you get there and you just absolutely... Where is the winch? Did the winch fly off? I think the winch flew off. '07's winch. You're a goner, Mr. Winch. Anyway. You have this almost equation for that's cool. It generates organic. That's neat. So you have this equation for moving mass to the speed of light x, right? Now here's where the fun begins. You're wanting to move mass. Speed of light squared, whatever. If you manage to move mass that far or that fast, what happens? Some people say that once you go faster than the speed of light, you suffer time dilation, and then you go back in time. But if that's true, then wouldn't Einstein's theory of relativity there, the equals mc squared, wouldn't that just be nothing more than a recipe for time travel? Seems a little weird. At least it seems weird to me. And so, knowing this, that it's effectively time travel, let's just go with teleportation. How do you find the mass of a human being? Through volume. How do you find the volume of a human being? Archimedes' principle of water displacement or fluid displacement. So what you do is you take a person and you submerge them in a pool. But you can't just submerge them in a pool because eventually they're going to run out of oxygen. Correct? Correct. So you can't hold Bob under the water and make him drown just for the sake of science. Even if you didn't like him at the office party, you still can't do it. So now what? Bob, you have to figure out how to get Bob and get his volume. So you put Bob in a wetsuit. Bob and the wetsuit go in the water. You measure how much water is displaced. There's your volume. Then you take the wetsuit and you throw the wetsuit in the same water without Bob and you measure it. Now you have the volume of the wetsuit. So now what do? You take Bob plus wetsuit minus wetsuit equals Bob. Now you have enough mass. Now you know the mass of Bob, and now you can send him back in time or teleport him. Now imagine the logistic hoops to have to jump through to bring teleportation to the real world. Every person would have to put on a wetsuit, get submerged, be underwater, and then they'd have to figure out how much energy. It would just be a big hassle. And by that time, people would be like, this is worse than standing in line for the TSA. And they would just decide, well, I'm going to get on a plane and just fly instead of teleport. So is teleportation possible? Yes. Is it feasible? Not yet. Now, if there's a feasible way to measure people's volume using a displacement technique that doesn't require you to fill a room with water, or fill a chamber with water, I should say, then you could potentially do it. Maybe you pressurize a chamber of gas, oxygen, if you will, or atmosphere. You pressurize it with whatever the atmosphere is made of, the nitrogen percentage, the oxygen percentage, methane, and so on and so forth. So the people breathing it won't notice a difference. You pressurize your chamber. You mark off how much volume is in there. Right? Then You have a person step through in an airlock. They go into an airlock, and then that's pressurized to the one pressure, and then they step through into the room. Now, in order for that to happen, they're going to, when they walk in, they're going to displace gas in the chamber, because you're now filling it with some form of mass, some form of volume that is not the gas. So then you find out how much is exhausted through the gas chamber on the top, through the pressurized chamber on the top. You find out how much atmosphere is actually exhausted, and that should tell you how much mass an individual is, assuming it works the same way as Archimedes' principle of water displacement. I don't think there's an Archimedes' principle of gas displacement, at least to my knowledge. If there is, let me know. But we managed to get to Calidor, we managed to get the core, and we managed to put it on the satellite. I did not get a third core because I didn't seem to see it was relevant to get a thermo to bring back, so it doesn't matter. However, I hope everybody enjoyed this video, because I know I did. Even though I didn't talk a whole bunch till the end, I hope everybody has a fantastic evening, wonderful tomorrow, and as always, have a good one.